Good morning. Sorry I can't be there today, but as the saying goes, I'm there with you in spirit, I suppose. This is 4.5, writing a function rule. Pretty simple, pretty straightforward. It is something that we have done before, so in terms of a brand new lesson, not really brand new. There's a lot that relates to things that you've seen before. So let's get started, shall we? First of all, we're going to be talking about writing. I can write equations that represent functions. I can write equations that represent functions. And there's really no background other than what you've done already, so no new vocabulary or anything like that, so we'll just get right to it. Writing a function rule. So what you're going to be doing is identifying triggers in the word problem that identify certain operations. So you're looking for keywords and numbers to be able to put together a function rule, more or less an equation. So you can estimate the temperature by counting the number of chirps of the snowy tree cricket. The outdoor temperature is about 40 degrees more than 1/4 the number of chirps the cricket makes in 1 minute. What is a function rule that represents this situation? Okay, so you've got some variables here. You've got, if you keep in mind a few things about a function generally there's an input value and an output value, so you're looking for two variables. And then there is some sort of operation taking place, and then you're going to also be looking for the numbers. So let's just take a look at some keywords here that are going to help you along the way. And for example, the outdoor temperature is. Okay, so I don't know exactly what the temperature is, but that's going to be one of my variables. I'm going to use T to represent temperature. Is, remember that's generally where your equal sign goes. And it says about 40 degrees more. Now don't get confused by the word about. We're not going to be estimating or anything like that in terms of writing our function, but potentially, when you start substituting values in, you would not get an exact value. So don't be confused by the word about here. At any rate, temperature is 40 more than. So here's a number, 40. More than would be a trigger for addition. 1/4 the number of chirps. Okay, so again I have the number 1/4. 1/4 the number of chirps. That would indicate some sort of multiplication taking place. 1/4 times the number of chirps that the cricket makes in 1 minute. So what is a function rule that represents this situation? I'm simply going to write this as an equation. So I recommend, you can obviously use y and x because you're going to be eventually graphing these anyways at some point. But you also have the opportunity to choose whatever variables you want. So I would use T to represent temperature, and I would use C to represent chirps, or you could use Y to represent temperature and X to represent chirps. It really makes no difference. So keeping it consistent with what we're doing, let's just use T. T equals, and 40 more than, of 1/4 the number of chirps. So 1/4 C. And that's really it. So why don't you try your best on this next one and come back in a second to check. Alright, so the function that you're looking for the got it question, if I'm using W to represent waste, total waste, it gives me M for months, so I should be looking at 50,000 plus 420M. W equals 50,000 plus 420M. We're starting with 50,000 tons of waste and then adding 420 per month. So there's that function right there. Let's move along.
Reserve seating is $25 per ticket. There are 10 rows with 12 seats per row. General seating is $10 per ticket. There are 30 rows of 16 seats per row. First, relate what you know. The total revenue is general seating revenue plus reserve seating revenue. How can a model help you write an equation? A model like the one below can help you write an expression for the general seating revenue. Add the reserved seating revenue to get the total revenue. The general seating revenue is the price per ticket times the number of tickets sold. Now, define the variables. Let R equal the total revenue and let N equal the number of general seating tickets sold. Now, use the relation to write a function rule. The total revenue, R, equals the price per general seating ticket, $10, times the number of general seating tickets sold, N, plus the reserve seating revenue, which is $25 times 10 rows times 12 seats per row. The function rule R equals 10 times N plus 3,000 represents this situation. There are 30 times 16, or 480, general seating tickets. Substitute 480 for N to find the maximum possible revenue. The maximum possible revenue from ticket sales is $7,800. Now it's your turn.
Take a minute and see what you can do with this problem, and then come back and check it. So we're looking at the function c equals 12 plus 15n. And if it was 10 days, 10 would get substituted in for n. That would make 150 plus 12, which is $162. So go back over here. And we have our situation that you're filling in right there with your all of this should go in there. C equals 12 plus 15n is your equation, and then $162. And there we go. Moving on. By the way, anytime you have questions you need to go back and review, please do that. You know the drill. Alright, so don't worry about the gridded response. This is just a type of problem that is offered in our lesson. Doesn't really mean anything to us. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet?
In this problem, you will write a nonlinear function rule. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of a rectangle when its width is 9 feet? How can drawing a diagram help you write the rule?
I don't personally like the diagram. I think it's much easier to do it from an equation, but let's see what she has to say.
A diagram visually represents the information in the problem. It can give you a clearer understanding of how variables are related.
So,
Step 1. Represent the general relationship first. The area, A, of a rectangle is the product of its length, L, and its width, W.
So there's your formula.
Step 2. Now revise the model to show that the length is 5 feet more than the width.
So we should be subbing 5.
Since the length is 5 feet more than the width, you can substitute W plus 5 for L. Step 3. Use this diagram to write the function rule.
W plus 5 goes in for L, we're going to multiply. Use the distributive property. W times W is W squared, W times 5 is 5W.
The function rule, A equals W squared plus 5 times W represents the rectangle's area.
So there's your formula. The only thing left to do then would be to substitute 9 in for W and calculate.
Now substitute 9 for W to find the area when the width is 9 feet. Substitute 9 for W and simplify. A equals 126.
Square feet. Don't forget the square feet because they're talking about area.
When the width of the rectangle is 9 feet, its area is 126 square feet. Now grid your response.
This is the part you don't have to worry about because we don't do that.
Now it's your turn.
Okay, so take a couple of minutes for this and come back when you're ready. Here's your formula. A equals B squared plus 2B. Remember, it's a triangle, so it's 1/2 base times height. Area equals then 288 square inches if you're substituting 16 in for the base, because then the height would be 20. Right? The rate of function rule, 4 inches more than twice the length of its base. Okay, I see. Alright, so maybe we spend a little bit of time here on this one. Alright, so we're talking about triangle. So area is 1/2 base times height. It mentions that the height is 4 more than twice the length. So height equals 4 more than twice the length. In other words, the base. Oh, it does say twice the length of the base. So 4 plus 2b, or 2b plus 4. So this value then would get substituted in for the h value, which is shown over here. A equals 1/2 b times the quantity 4 plus 2b. So then after that, you're going to use the distributive property to multiply 1/2 b times 4. 4 times 1/2 is 2. That would be the 2b. And then 1/2 times 2 is 1, and b times b is b squared. So that's where the 2b plus b squared comes from. Remember, commutative property, you can flip those two around, so it could also be b squared plus 2b. And then if you substitute 16 in there, 16 squared is 196, I believe. 16 times 2 would be 32. Add those together, and that's where the 228 comes from. Okay? Questions about that, go back and review. Otherwise, you are free to try the self-assessment on your own, and then come back when you're ready to check answers. Alright, so you're starting with 628 tires. Each day a total of 80 tires are sold, which means they're being subtracted, right? 80 tires per day are being subtracted from the 628 that they started with. So whatever letters you used, it doesn't matter. Y equals 628 minus 80x. The plumber charges a service fee of $50, so that's your $50 flat fee, plus 35 per hour, so 35 times a variable. Y equals 50 plus 35x. And then how much would it cost to work for 6 hours. So you would substitute 6 in for 35. 35 times 6 plus 50 would give you $260. Number 3, triangle. So 1/2 base times height. The height is 6 feet more than the base, so that would be b plus 6 would get substituted in for h. And the area of the triangle then, when the base is 10, would be 80 square feet. 80 square feet. Okay? All right, so you have a homework assignment to do, which should be at the bottom of the page here, 265, numbers 8 through 21. And then you have the corresponding IXL activity Z12 in the 8th grade tab. I personally don't mind if you work on the homework with someone. Please do not give the sub a hard time. I left very, very specific notes in the sub plans as to what you are to be working on. Don't forget you have 20 IXL skills that you need to have mastered by the end of the day. So please use your time wisely. If you need to play catch up, now is the time to do it. And I will hopefully see you tomorrow. Have a great day, guys. Yeah, one quick thing, by the way. I said what did I say? 16 squared is 196. It's not. It's 256. So 256 plus the 32 gives you the 288 square inches, I believe it was, for this got it problem. So apologize for the mistake, but you know what you're doing. It's early. I didn't get a whole lot of sleep last night, so apologize for that. Anyways, have a great day. See you tomorrow.